I'm Nolan McCann, and I'm here with Kettering University. This is Kettering's biogas vehicle. It runs on biomethane, compressed natural gas, and gasoline. It is a 2009 Chevrolet 2500 HD pickup truck. It has the V8 gasoline engine in it. This project was completed as a partnership between Swedish Biogas, the Flint Wastewater Treatment Plant, Kettering University, and the Michigan Economic Development Corporation. There are also several other sponsors involved in it. They include Baytech Corporation, who provided the compressed natural gas conversion kit, Swagelok, who is used for all of the fittings and the hard lines and that sort of thing, and Lincoln Composites, who supplied the compressed natural gas tank located underneath this cover. Some of the benefits associated with running on biomethane include lower emissions. It's comparable to gasoline in terms of fuel economy. Running on compressed natural gas and biomethane, they can be used interchangeably as they are both 90% methane. If you're using just compressed natural gas as a fuel source, it's cheaper. It runs about $1.90 the last time we filled up for a gasoline gallon equivalent. But of course, biomethane is preferred to compressed natural gas as it is a fuel generated by human waste. It is much cleaner to produce. Underneath this cover is the compressed natural gas or biomethane tank. The cover is used to protect the tank from the elements, rain, sunlight, that sort of thing, just to keep it safe. It also will extend the life of the tank as well, being kept secure from that. The cover also allows the bed to be used as a truck would normally be used without worrying about interfering with the tank and all of the lines and that sort of thing. So this is the compressed natural gas tank. It is a Type 4 tank. That means that it has a plastic liner, which is then wrapped in fiberglass and then finally wrapped in carbon fiber. So it is a relatively lightweight tank. It is rated for 3,600 PSI. There are also 3,000 PSI varieties, but this is the higher of the two. The tank is roughly a 21 to 23 gasoline gallon equivalent. So that means that there are roughly 23 gasoline gallon equivalents of compressed natural gas that can be stored in the tank. There are two mounting straps on either side of the tank, which are bolted to the bed, and then there are reinforcement brackets underneath the bed to brace it, so that in the event of an accident, it will not move. It is still safe and securely mounted. At the outlet of the tank is a filter element. The filter is used to remove particulate matter and moisture before the biomethane or CNG goes into the engine. There are hard lines used for all of the gas piping from the outlet of the tank to underneath the bed, inboard of the frame rail, all the way into the engine bay. Here we have both fuel doors for the truck. This is the factory fuel door. This is where the gasoline is put in. We chose to add another fuel door for refueling the compressed natural gas tank. This is the filling receptacle for the tank. It has a rubber cover that goes on top of it. There is a quarter-turn shutoff valve inside here for safety reasons that allows you to turn off the gas flow from the tank to the rest of the truck. This is the filling nozzle used to fill the tank. It slips on and then locks down. If this were an actual CNG filling station, it would be filling the tank right now. This takes usually 3 to 5 minutes depending on how full you want the tank. If you're comfortable with only getting it 70% full, that happens in the first minute or so. The tanks, as I said earlier, come in 3,000 and 3,600 PSI varieties, so there's a slight issue between filling those. The way it's set up is such that a 3,000 PSI filler nozzle will go over a 3,600 PSI receptacle. However, a 3,600 PSI nozzle will not go over a 3,000 PSI receptacle. On the interior of the vehicle, the only changes were the addition of 2 hour meters below the dash so that we can monitor how much time is spent running on each fuel source. In addition to that, there is the CNG fuel gauge in the center here, which is a simple 8 LED gauge going from E to F, and this represents the tank pressure. This is monitored from the transducer underneath the truck. As you can see, once the tank gets down to 1 LED, the system switches back to running on gasoline as indicated by this light. This is the engine bay of the compressed natural gas truck. The major change here includes the addition of the CNG fuel rail on top of the plastic engine cover. There are also some wiring changes that can be seen here and here. Those are for intercepting the fuel injector signal. So instead of firing the factory gasoline injectors, that signal is used to fire the compressed natural gas injectors, which you can now hear started firing. The gas comes, again, from the tank, through the regulator underneath the truck, then up through the back of the engine bay, coming into the back of this block. And then from the distribution block, there are 8 injectors, 1 for each cylinder, and then tubes running from the manifold into the intake manifold. In the intake manifold, there's a flat spot right next to the factory fuel injector location where a fitting is tapped in and these hoses are connected to. This is to ensure that the gas is mixed in an ideal manner in the intake manifold. The switching occurs automatically either when the engine reaches operating temperature or 30 seconds after it is started if it's already at running temperature. The only way you can tell that it's changed over is by hearing these injectors, which is virtually inaudible outside of the vehicle with the hood closed and certainly inaudible inside of the vehicle. You cannot feel the change at all when driving it. So with comparable horsepower and torque and similar fuel economy to gasoline, but with reduced fuel cost, biomethane-powered vehicles present viable alternatives to gasoline vehicles. With the continued support of the Department of Energy, the MEDC, and Kettering University faculty such as Dr. Ahmad Hormovahed and Brenda Lemke, the opportunity for future growth of the technology can continue, hopefully one day giving us production vehicles running on a green, renewable energy source.